So some of the points I have compiled for us for the discussion. And apart from that, some more supporting points are there, which are very much needed so as to complete our understanding. And once we observe these things, I'll give you the default and as well as possible storage levels related to our RDD, right? Okay. Now we have seen some implementation related to the persistence and as well as the caching. We clearly know that Spark RDDs are lazily evaluated, and sometimes we wish to use the same RDD multiple times. Okay, that means the dependency. As I said earlier, just we're having the RDD, and this RDD1 may be source for RDD2 and RDD3. Okay, this happens uh, general in general, guys, because a particular RDD is there where there is a dependency of this RDD with in the computing of other RDDs. So if we do this naively, Spark will recompute the RDD and all of its dependencies each time we call an action on the RDD. It is pretty known, like RDD1 leads to RDD2 and then RDD3 is a sequential kind of the flow. Okay, if any problem is there, then again we have to go back and compute the entire uh, calculation. So obviously, guys, because actions are nothing but the triggering points, where though transformations are lazy, but this action motivates the transformation so as to execute. Now this can be easily expensive, like definitely expensive in the iterative algorithms. Iteration means repeatedly if I want to perform, then especially in terms of usage of the data at many times. So, and moreover, if I want to perform counting of something or writing the data into the RDD, in those kind of the situations, this is an expensive operation. Okay. So to avoid the recomputing and using the existing RDD, okay, then we can go with the persist. That is the underlying assumption, guys, because it's not like simple, okay, whenever I wish I can do the persist. It's not like that. There is some analogy and basic evidence related to the persistence of the RDD. Okay, so one simple and direct point is to avoid computing multiple times, we can ask Spark to persist the data. Okay, then when we ask a Spark to persist the RDD, the nodes that compute RDD store their partitions. See the important point. Now node partitions. Partitions we have studied exclusively, guys. Data partitioning. In fact, in the earlier session, uh, that's what I'm saying. All the topics are they're having some connectivity, so that if you complete these architectural understanding, you can complete the circle of learning actually. Okay, and if a node that has data persists on its fails, Spark will recompute the last partitions of the data whenever there is a need. Because see, just if you are considering this thing, this is assume that persist. And if any problem is there for RDD2, no problem. Again, RDD2 can get back the information from RDD1 because it is having the previous results. But whereas if RDD1 itself fails, that is the point, guys. RDD1 placed in the machine, that machine is having some sort of the partitions. And if that RDD1 fails, Spark will recompute. Okay, so this is what you call the resiliency. Okay, because RDD itself is having the property of the fault tolerance. Friends, here one more important point in the exam also they ask like due to the persistence, Spark is having the fault tolerance. No, Spark by design having the fault tolerance mechanism by design. Okay, Spark by design having the persistence mechanism. Reason is pretty simple. In terms of the RDD, though you are not persisting the RDD, though that RDD is not caching in the memory, but still your RDD is having the capability of recomputing. Spark is having the resiliency, and as well as the lineage properties. With those kind of the properties, the failed RDD can be recomputed. Okay, there is a distinction due to the persistence. Only the thing is we can preserve the RDD without computing many times. That is only to avoid the multiple computations. But it doesn't mean that with the caching or with the persistence only Spark is having the fault tolerance. No, Spark by design is having the concept of the fault tolerance. With the advent of the persistence or caching, we can avoid the multiple computations. Okay, that is the hope. It makes sense. Okay, and we can also replicate our data on multiple nodes if you want to be able to handle node failure without shutdown, slow down. So because some of the nodes, okay, maybe as a key playing a key role where from that particular RDD the other computings are happen. In that particular case, guys, you need not worry about that. Maybe you can replicate these RDDs into another thing. That's what I said. Serialization, disk and memory replication. Don't worry. If any problem is there for the in memory, then obviously I can pick up the data and I can process my data. Okay, so these are all the points are the connected dots while working with the persistence and as well as the caching mechanism. Now, some more aspects to consolidate the things. One of the most important capabilities in Spark is persistence. Okay, the data set in a memory, and of course, feel that data set might be either RDD or data frame. And friends, here data set is available in Scala actually. Okay, but whereas in Python, especially in PySpark orientation, we don't have any construct like data set. Okay, like PySpark is supporting the RDD data frame along with the Spark SQL. There is no restriction on the Spark SQL. Right. When we persist an RDD, this is important point, guys. Each node stores any partitions of it that it computes in memory and reuses them. See, it is having the partition information, and whenever there is a requirement of the corresponding persisted RDD, with the help of these partitions, it is going to recompute. Okay, in memory and reuse them. So main purpose is reusability and avoiding the multiple computing. And we can mark an RDD to be persisted using the persist, or either you can use the cache also, guys. But stick to one thing, because how we are checking is initially we checked that is cache. We checked and RDD1 dot persist like that we are using. So stick to the basics. But of course, uh, either you can use the caching mechanism or persist mechanism related to the RDD orientation on it. The first time it is computed in an action, it will be kept in memory on the nodes. Uh, Friends, here you need to observe that while performing the action, because at the moment I am persist, it performs some kind of the action. So it reflects into the is cache. So that earlier maybe you would have got false. Now once the persist is over, your RDD is cache returns to true. Both the things we have verified in fact. So Spark's cache is fault tolerant. If any partition of an RDD is lost, it will automatically be recomputed using the transformations that originally created it. See friends, how simple is, like, let me show you this. RDD1 equal to, just I am making use of the text file of some path. Okay, and I have given some uh, 10 partitions. Now RDD2, what I'm doing here is RDD1 dot map of something. Now RDD3, RDD2 dot flat map of something. Similarly, sorry guys, similarly, I'm making use of something. Maybe I can use RDD1 or RDD2, or let me take RDD3 only. Some filter condition. It's a chain of activities. Now what they are saying here from this thing, suppose if any partition of RDD is lost, any partition means assume that guys our RDD2 got failed. This partition got failed. Now you see the immediate effect is with RDD3 and RDD4. But you have applied persist mechanism on RDD1. So automatically you need not worry about this RDD1. So our partitions are available in memory, and RDD2 just will be transformational, just we are computing some sort of RDD2, and then whichever the dependent RDDs are there in a kind of the sequence it is going to compute. So the analogy behind this is there are places where one particular RDD failure may be reflecting in multiple RDDs. Okay, generally the latest results, whatever we are having with respect to the RDD, if that RDD fails means the leading all RDDs getting into the trouble, guys. Now, if you consider the last option, okay, if you are considering the last option, so suppose the last point, each persisted RDD can be stored using the different storage level. Now, actually the thing, guys, because we understood that like what is the persist and how we can cache the appropriate RDD, and how is Spark managing the consideration related to this convention. Now these levels are set by passing a storage level. And if you consider the storage level, just we have imported the storage level. And after importing the storage level, we can put this particular storage level dot memory. And we know this thing actually, memory and disk too. Apart from these things, first let us understand what is the storage level. Storage level is a mechanism provided by Spark to the developers of the Spark, so that the developer can decide whether I want to preserve my data in memory or memory along with the disk, and I can specify the replications also, or else I want to maintain the serialization, or else many such kind of things are there, friends. So here, as I asked, what is the difference between persist, cache and storage level? Persist is a mechanism of deciding whether you want to preserve your RDD in the memory or not. If you are committed to the persisting of the RDD in the memory, it will be cached, and your is cached returns true. And of course, if you are not giving any storage level, by default, it go to the memory only. It do not prefer, because Spark is a the design principle of the Spark is in-memory computing. But second important consideration, guys, where your Spark storage level allows the programmer so as to specify whether I can enjoy the benefits of the memory only or memory and disk with replication, all these kind of the convention. Storage level is a flavor of persistence. On what way you are, though Spark is providing the default specifications of the persisting of the RDD, but still it is user wish, it is the developer wish, so as to focus on changing of the corresponding storage level. Okay, now the most awaited kind of the storage levels we are having. So because different storage levels we are having, guys, where that comes under the category of the persistence, and at least one or two questions we are getting, guys. Okay, in terms of persistence, cache and storage level. So just you focus on this particular thing, and that it's not a big thing actually. Okay, now if you consider, guys, in the beginning of the persistence understanding, first we got the at the time of printing get storage level, we got the false and then true, and thereafter false, and then we got false and then 1. If you observe this thing, okay, get storage level, whatever the RDD1 dot persist dot get storage level. If you are recollecting that particular thing, guys, definitely you can remember this aspect. Okay, false, true, false, false, comma 1. Now this particular storage level, the analogy behind this. I'm having one more thing, guys. What is the specification behind that analogy? Yeah, actually, I want to give some other reason for that. So as an addition, because directly if I'm opening up with the storage levels, it may not be complete. We are having some more supporting document, guys. Uh, if you are considering the storage level, because there we are having total 5 parameters na. So out of the thing, first, second, third, fourth and fifth parameter. First, we should know that what is the parameter. This is the replication, guys. That's what we are having the 1, 2, something like that. And your first thing is use disk. This is the disk. Second thing is memory. Third thing is heap, deserialized. Simple. Serialization, maintenance of the state of the object, vice versa. Okay, in terms of Java also you might be having this. Now it is pretty clear that your first argument is true, means you are preferring disk. Your second argument, however it is true, by default it is also, it is referencing to the memory. If you want to maintain heap based kind of the memory, because that is JVM based kind of thing, friends, I'll give that thing for the self learning because that is bit JVM relevant aspect. Maybe I can ask you to give the presentation as a webinar kind of thing, maybe 10 to 15 minutes. I'll maybe for Vedant or somebody else, Neha or Surendra, okay, who is very interactive. So to those guys, definitely I'll allocate that topic. So heap and deserialized will see that. But observe that if you want to maintain the deserialization or heap memory kind of the thing, then these third and fourth options are also should be true. And fifth one, however, is a number. If it is one, means replication is one. If it is two, means multiple files are there along with the memory. Maybe I'm having the disk also. And data can be stored either in disk or memory or off heap memory or any of those combinations. This is the beauty. It's not R only. Any of those combination, disk memory, disk off heap, like that we're having. Data can be stored in a serialized or decentralized. Serialization is a way to convert a object in memory to series of bits. If I want to prefer those kind of the bit based storage, I can go ahead. Now, let us clarify what exactly deserialization is. The process of bringing those bits into memory as an object. Whenever we are talking about RDD or data frame, we are always referring RDD data frame in memory. Now see, friends, here. Serialization or serialized bits, nothing but whatever the object we are having, these things will be converted into the bits. Bit 1, bit 2, bit 3, like that, some storage locations. Whereas your deserialization, what it does is all these bits will be combined into memory as an object. Now it becomes the object because RDDs or data frames are always preferred to access the data into the bunch of bits or as a kind of object. So it is more flexible for maintaining the appropriate aspects with respect to RDD or data frame. Now let us understand this off heap memory is a segment of memory lies outside the JVM. Important point, guys, because we always say that these Scala or PySpark run on top of the JVM based kind of thing. But if you want to maintain your memory other than the JVM, outside the JVM, but it used by the JVM for certain use cases of half heap memory can be used by Spark explicitly as well to store serialized data frames and RDDs. Sometimes, guys, if I want to maintain RDD or data frame in the serialized manner, and other than the JVM, if I want to store these things in memory, like, I can give some analogy, guys, here. Like if you see the RAID architecture, redundant area of inexpensive disk space, maybe database practitioners or data warehousing practitioners who is having the inclination of studying the optimizations or memory based kind of the functionalities, they can easily get this idea, friends. Okay, rather than JVM based kind of thing. Other than that, if I want to maintain my data, which is the off heap memory kind of aspect. And the user replicated storage levels if you want fast fault tolerant recovery or fast fault tolerant. Suppose if any problem is there for the in-memory friends, again the Spark need to go back and verify in the source data. But whereas if luckily it is there in some other location as a replication, you need not recompute actually. So getting back the appropriate RDD, which is replicated is easy and faster, easy in the sense faster. But whereas if any RTD is not replicated, again Spark need to go back to the source and recompute with the help of the lineage and resiliency property. With these two properties only, it is going to pick up and compute the aspects. So to avoid that particular convention, of course, based on the capacity of the RDD, based on the reach of the RDD, because sometimes based on that particular source RDD, all the other computings may be performed. In that particular case, it is always preferable to maintain that dependent RDD into various replications. Now you can see easily here. Okay. Now, if you observe this default storage, of course, your second thing is memory. That's what it is true. It is connected and your replication is also one. So default storage in RDD orientation is memory only. Now one question they asked guys actually. One question in the um, examination, Databricks examination. Suppose if RDD is there, not RDD, data frame is there, which is cached, and they prefer to use the hard disk. Okay, then what is the storage level of that? Okay, so what is the storage level of that? Think through, guys. It is a data frame. Of course, it is cached. Definitely, it is having the persistence mechanism. They want to store in the hard disk. Then what could be the storage level of that? Definitely, it is not the default because default, memory only, which is false, true, false, false one. Other option, guys, actually, if you consider the only disk means memory and disk, guys, actually, they don't want to save that particular thing in the memory also. Already computation is over, but they want to preserve these kind of the questions they frequently ask. If you are not cautious, what you'll do? Oh, memory and disk with the two replication, but they don't want to maintain the things in the memory without replication. Without replication, you have to see memory and disk. Okay, disk is true, memory is true, and of course, third is the off heap. Next is the deserialization, and your replication is also one. Okay, so like that, you need to venture the things, guys. And disk only. However, first option is true, remaining all false, and there is no replication. Disk only 2 means first obviously true, and there is a replication factor 2, remaining all false. It follows memory and disk without only one replication. First two parameters are true, remaining are false. And memory and disk with two replication, then definitely replication factor is true. Memory and disk, first two parameters are true, remaining are false, obviously. Now you see here, guys, memory and disk with the serialization. Memory and disk with the serialization, of course, true, true. Replication is one, false and false because deserialization is true, guys. Just you observe that convention. Okay. Now memory and disk with the serialization, replication is true. So both first options are true. Third, fourth are false, and this is the replication too. Memory only. This is by default where your second parameter is true. All are false with replication as one. And this is quite interesting, guys. It is quite interesting. Memory only two. So now tell me, how do I get this particular thing? You may ask this question. Suppose if I'm asking you guys also, memory only two. What is the analogy behind that? think through how can we observe that kind of the convention? Memory with two replication. Is there any specific convention on that, guys? Memory and disk. Only memory with the two replication. Okay, it is a typical replication where within the memory itself we are having multiple RDDs which are doing the same thing. Suppose I can say broadcast is there or accumulator is there. Broadcast variable which is cached in all the disks or all the cache kind of things. And without recomputing, okay, without resilience or lineage property, that is by default available. In those kind of the situations, guys, just we can make use of the memory only too. So first thing, however, referencing the disk, false. Second is referencing the memory, true. Remaining things, we don't want heap or deserialization, but we want replication. Okay, within the memory, if I want to maintain multiple RDD copies, is a pure replication actually, because in terms of memory and disk, that replication is most common. But whereas inside the memory, if I want to preserve multiple copies, though at the cost of the memory, I want to preserve that RDD. See how benefit that particular, how priority that RDD we are giving. Okay. Now memory only serialization, nothing great here. Only this one and replication is one. Maybe sometimes, you may be getting the same kind of the analogy, guys, somewhere. Okay, just observe that. Observe those kind of the aspects. Memory only serialization with replication two. Okay, false and second is true. Finally, off heap. Heap, of course, third. Na? So true. Friends, here the point is if you are selecting off heap, by default your memory is in force and your disk is in force. Okay, along with the heap. Maybe you may be getting this kind of the question. If I am selecting the storage level as heap, then what about the memory and disk based storage? Both those two are satisfied. Both the disk and memory oriented aspects are also satisfied. So this is the way how you can manage the convention of storage level, persistence, and as well as the cache. Friends, this point why I am focusing or stressing or emphasizing is first point is the entire analogy of the Spark architecture you can get from this topic. Second important thing is how Spark is storing the data level wise, maybe in terms of the memory, disk, off heap, deserialize, replication. Okay, like 5 types of the storage level it following. And each and every parameter is having some sort of the notion, some tagging with the corresponding aspect. Like the first parameter is related to the disk, second parameter is related to the memory, third one is related to the heap, fourth one is related to the deserialization, fifth one is related to the replication. You should remember all these particular things. Why I'm using should is just interchangeably we are getting the questions from those kind of aspects. Okay, so this is what how we are making use of the convention of our storage level. Okay, maybe again you go back and see how we are maintaining the convention of the storage levels. Question, yeah, let me see the questions. I love to answer those questions, guys. So where is our cluster? Yes. Oh, our cluster is still running, guys. Thank God. Otherwise, we need to create one more. Let me push. Okay. Now, yeah, let me go back. Surendra is asking, deserialization better than serialization. Is deserialization better than the serialization? Let us understand what exactly the deserialization from this particular analogy. Okay. So definitely we need to see once again so that you can be clarified, right? Okay. Now see guys here, deserialization is a process of bringing those bits into memory as an object. Whenever we are talking about RDD or data frame, we are always referring to RDD data frames is in memory. Suppose you are running some task or some kind of the application. maybe you are working with some data frame, and maybe you want to get some sort of the memory relevant aspect. And that object is serializable in the sense B1, B2, B3 bits individually we are having. But as a whole, guys, if I want to work with, because in memory computing we are talking, okay, make a note on that. We are talking about the in memory computing. If it is in memory, again, these particular serialized in the sense maybe somewhere they would have stored. Okay, maybe assume that in the disk they are having. Now, friends, always getting these individual bits to license the appropriate operation always takes more time actually. So what we are doing is we are deserializing all these bits. We are instructing, we are giving the storage level like deserialization so that all the bits will be combined as an object, and this object is handy. It need not verify where these individual bits are there, and it need not go and search for the individual bits. Rather, what it can do is, as with the property of the deserialization, all the individual bits are tagged into one common object. Though they are physically available in different locations, logically they are tagged with one kind of the object. So for RTD or data frame, it is enough to contact the object rather than talking with the individual bits. Now, simple thing, guys. Suppose Surendra is handling one project, and under Surendra we are having XYZ members. 3 members are there. Rather than taking the individual status, XYZ status, I can ask Surendra directly so that he can give the status of his team members, because he is the point of contact, so that he is having entire updates provided. He should have the updates on X and X, Y and Z members. Similarly, rather than taking each bit B1, B2, B3 into the memory and tag them according to the requirement, if you serialize that particular thing while performing the operation in the in-memory computing, so obviously your bits will be concrete into the common object, at least logically, and it is enough to contact that particular object by either RDD or data frame, so that one can easily fetch the information without traveling much. Is a locality based kind of thing, friends. Okay, I can say definitely deserialization is better when compared with the serialization, provided if you are handling the in-memory based kind of thing, especially in terms of RDD and data frame. You may ask this question: why explicitly we are mentioning the RDD and data frame? There are certain other options also there, friends. Without using RDD or data frame, lot more you can perform. Like individual data items I can take. And see, without RDD, just I'm having the accumulator. I'm having the broadcast. In that particular case, we are not preferring the deserialization. Whereas in terms of RDD and data frame, definitely it is much more helpful and much more handy compared with the other kind of the conventions. Okay. Now, just we are coming to the data frame understanding, guys. As usual, our analogy is first. Let me introduce. Okay, good, Surendra. Keep me posted. Keep posted so that I can come back and see. Don't wait. Just I appreciate your questions, guys. Neha, Surendra, and even Suryana. So those guys definitely put good questions. Okay, I don't know why Sahu and Vedant, Shanmuga are quiet. Okay, I'm expecting questions from you guys also. Okay, right. So now, friends, here the initial points I want to discuss, like the data frame aspect. Now, I don't want to define data frame first. First, I want to create the data frame with some sort of the list. Okay, there is a first methodology. Okay, let me give the running serial number. And in fact, from the next session also we can keep that momentum. Like RDD, it is pretty easy. One is with the parallels, sorry. Second is with the range, and third, I'm using that CSV files or something text files to create the RDD. But data frame is not limited to these three guys. Okay, we are having plenty of mechanisms where you can manage your data frame orientation, like starting from the list and all these kind of the conventions. Okay, so just let me give you this convention: data frame creation with list. Actually, there are collections actually in Python, is a kind of running or iteration kind of thing where many conventions can be followed. Okay, we just starting with list based data. Initially, I want to create some list friends here. Uh, just you might be knowing, if I want to create multiple list, then I need to create multiple brackets. So it is considering each and everything as a individual entry. Just I am giving the some kind of the data. Just what I'm doing here is just I'm creating some sort of the information. Uh, Later I will give you the schema information. Okay, and then I'm giving the qualification, and along with this kind of the convention, I'm taking one more. Um, so 1022, sorry, it's a dictionary kind of thing. And then Rendra, just I am making use of data science domain, and then just I'm taking this convention, right? So if you observe up to this some kind of the list related to one person, and from this particular perspective, just we are having the another employee data, but we are not clear what exactly the schema. Maybe the whether this is the social security number or employee ID, I'm not sure. Whether this is the domain or specialization, I don't know, but at least we can see that this is a qualification. Now let us run this. Simply, we are getting the list is a typical list. There is no reference of the data frame, just is a list creation. Now you can see here how the data has been created. Now, the typical development of this thing, guys, just the columns I am defining for the clarity. So just I am giving the employee ID. And second thing is name of the employee. So just the schema I'm defining here. And next option is, of course, the technology. Okay, technology as they are working so that we can contact them. And fourth one, of course, qualification. Okay, so just I'm making use of that columns list. And this particular column, if I'm taking, just it is also a list. Uh, okay, columns actually. So just it is also a list. Just I am taking the employee ID, employee name, technology, and qualification. Okay, now how do I make use of these two conventions? Because in RDD, if you remember, guys, there is no schema actually for the RDD. For RDD, we never talked about the schema. Now we are introducing the term related to the schema. Our first data frame, just we are creating, and of course with the object Spark. Now see the differentiation. Up to now, majority of the times we have used SC, Spark context, in terms of RDD, in terms of accumulator, in terms of broadcast variable. In all those kind of directions, we have used the Spark context. But now, as I said earlier, though I have not given the conceptual aspects of the data frame, but I'm trying to give you the essence of that. Data frame is a high level API which is built on top of the RDD. Okay, based on that RDD, so that whatever the functionalities we are having in terms of RDD, but uh, in some of the cases, friends, I'll bring those cases also periodically after getting some understanding of the data frame. There are certain chances where data frame may not be able to directly deal with, especially in the memory orientation, in the partition kind of things. Maybe some aspects where data frame cannot be interact with them directly. In that case, definitely we have to dependent on the RDD for the sake of interacting with the low level aspects. So I mean to say data frame through RDD only, we are going to interact with the low level aspects like partitions or memory oriented kind of things. So just I am notifying you, like we're having one function called create data frame. and let me show you what is this create data frame method does. So create data frame, just union of the data, any see here, maybe it is RDD itself, or else it may be iterable, or it may be the pandas data frame, or it may be the array. Like schema also, guys, just we need to mention the schema, which is the strength of the data frame actually. What I'm talking here is, suppose I designed some data and I want to present my data to the client or to the leadership so as to explain that. Because as a developer, you know all the in and out of that particular implementation. But for the functional users, okay, so as to convey the information, definitely we have to maintain the high level details. So such a kind of high level API is our data frame, where it is not denying the usage of the RDD. Along with that particular RDD, it is allowing us to work with various collections and all these arrays, all the possible aspects. Now periodically we'll be seeing all these options, guys. Now it is enough to have this data and as well as the schema. Data, however, we are having the information. Schema is just now we have defined in the COLS, where employee ID, name, technology and qualification. Now what exactly this data frame does is creates a data frame class, and from an RDD, or else a list, or else your pandas data frame, or else from array. Okay, there are plenty of avenues where you can make use for the creation of the data frame. Now, what exactly the schema? When schema is a list of column names, the type of each column will be inferred from data, which is excellent aspect, guys. Like, you need not tag them individually. Okay, you need not tag them into a common object as how we have seen in the deserialization. But your data frame, at the moment you are giving the schema, in that particular order, automatically it is going to assign the corresponding data type. In fact, the main advantage of mentioning that particular schema is to notify the data frame about the data items of the corresponding values which are there in the data. So when schema is a list of column names, the type of each column will be inferred from the data. Okay, so it is inferring the appropriate data item, and the corresponding data type is replicated in the schema, whatever you have defined. Now, when schema is not mentioned, this is also important point, guys. It will try to info the schema. Sometimes we are not interested to maybe 10 or 20 features might be there. In that particular case, directly, I am not explicitly mentioning the schema. Rather, what I can do is I can directly refer my schema from the appropriate values. So it will try to info the schema like column names and as well as the types from the data, who should be an RDD of either row. Okay, I'll introduce this thing also, guys. Class, name tuple, excellent topic, and dictionary. A dictionary is more preferable compared with the row and name tuple, because, guys, dictionary is a key value pair kind of aspect. Most of our data frames in the projects also, simply you can define the dictionary because it is quite handy. You can also realize while implementing these data frame kind of the orientation with RDD, with pandas data frame, with some sort of the list. Okay, and with the dictionary also, then you can clearly observe that with the dictionary, which are all the flexibilities we are going to acquire while reading or while studying about these kind of the convention, right? Okay. Following, like we are having the data type, while that is what, friends, for the first time, just we need to focus on these kind of the things. 90% of conceptual understanding also comes here only. That's what, rather than directly moving to the one note, I planned like this. Just we are studying the documentation because this language is important. The same language will be talking with clients or your team members or seniors, along with this Databricks kind of certification also. So these types, and most importantly, guys, one more aspect we need to study is the structure type. Struct type is quite interesting, where you want to define your own data types for the schema. You want to explicitly mention that schema information related to the values. Maybe the programmers from C, they can easily relate this, guys. I'm sure. A reason is we are having the structure data type in C, where we can define a structure with respect to the members along with the corresponding data type. So here also I can make use of the structure type, which is a structured kind of the data. Within that struct type, I can define various members, various structure variables. Okay, so that also we are going to talk. Uh, and some of the examples, guys, here. So I strongly recommend you just to make use of these examples, which are pretty simple. But I thought of giving you some other examples rather than this one. However, you can work whatever the examples we are talking in the session along with the examples given by the documentation. Okay, but just to feel that make use of this documentation and try to implement these examples also without fail. Now, so just to the basic syntax related to this particular creation of the data frame. Already we are having the data with us and as well as the columns. That's all. So the first option is of course the source data. Second option is related to the schema. Now we could able to observe here the convention. You click on this. So nicely arranged employee ID. Okay, long employee name string, technology string, qualification string. We did not mention any data type, guys, but based on the kind of the data you have given, obviously the a Spark able to assign in terms of the with the help of the create data frame. Now there are some other functionalities. If I'm giving this thing, RTD, guys, some of the aspects we can see, but whereas in data frame, plenty of things are there, guys. At least 50 to 60% we are going to deal in the sessions, and remaining 20 to 30% definitely I'll give you some sort of self-learning so that you can manage, right? Okay. Now all these kind of the conventions, there are certain options where I can use. One of such kind of option is print schema. So just now we have seen what exactly the schema is. The schema gives some kind and typically a database developer or who is having the SQL and PLSQL background, they can easily observe what exactly the schema, the overall design of the database. Similarly, here also schema gives that some sort of, okay, what is your column name and type of the data, data type, all these kind of the convention. Now, one more thing, guys, here DF1. Actually, we are having. Uh, I'm trying to collect the data. Okay, just observe here. You may be observing one important notification related to the row. Okay, this is one row. This is another row. And similarly, if I'm giving take off one, so still whatever the functionalities related to the RDD, these things also helpful, guys. But only the observation is here. If you are using collect or take, um, they are giving the low level reference of the row. Okay, so row is also one of the possible source to create the data frame. But here we have created our data frame with the list, but at the end it is again showing the row wise. So to avoid that confusion, what you can do is just you can make use of df1.show. Now you see is a nicely managed thing where exactly this particular expectation, like how your query, SQL query is returning some row and column wise fashion. It's nothing wrong to use collect or take, guys, but only the distinction is collect and take or revolving around RDD, so that the way they are reflecting the outcome is also in terms of low level or RDD orientation. But whereas your show method is something like which is a fine-tuned version, which is tailor-made for your data frame. Just it is getting the kind of the convention. So with this, just we have understood the data frame basics. I'll take 2 more minutes, guys. Let me clear what exactly the data frame and how we are making use of this particular data frame, all these kind of the conventions, so that from next session onwards, just we'll try to reference the data frame and then we can go back and study about various ways how to create. And in the tomorrow session, CSV, text-based, Parquet, range, and as well as the dictionary and other data frames. I mean other RDDs, other some kind of the pandas data frame. Likewise, we are going to talk. But let me consolidate understanding of this particular data frame. Friends, just we are going back to our OneNote. Have a look on this, guys. It won't take much time. A distributed collection of the data grouped into named columns. Grouped into the named columns. That is the first thing, a distributed collection as that of the RDD. And second thing is a data frame is equivalent to a relational table in Spark SQL. Not at explode, but you feel that this is a SQL table kind of thing, your data frame, and can be created using various functions. Various functions in the sense one is 2DF, another is create data frame, and like that with the help of the range, like that you can create, and you can manually create a PySpark data frame using T2DF, just now we have mentioned, and create data frame method. Both these functions take different method signatures in order to create data frame from existing RDD or list or data frame. Now we have seen some list. We have created data along with the schema columns and tagged together with the help of the create data frame so that we can able to generate a fine-tuned data frame. And you can also create PySpark data frame from sources like text file I can take, CSV, JSON, ORV, Avro, Parquet, XML, like that. And of course, guys, if you are running Jupyter Hub on top of your Hadoop distributed file system, in that particular case also, if you are making use of this convention, in that case also I can access my data from HDFS. Maybe Spark, I'm running the appropriate functionality on top of that Hadoop distributed file system. If I want to load the data, if at all I want to manage heavy data and I want to process the data for the sake of the analytics. And long back we have seen how these particular tools are complement each other, right? So with DBFS, now we are seeing actually Databricks Community Edition, or else in the proprietary edition also DBFS is the base root actually, and Azure BLOB file system, etc. So these are all various sources where I can venture my understanding of the data frame. And along with that convention, and one more point I want to clarify here, uh, that is the Parquet file. Why we are giving Parquet that importance? And before coming to the tomorrow session, guys, I insist you, okay, I insist you, uh, Parquet importance and how Spark getting advantage of using this kind compared with the others. Okay, compared with other types. This is probably the task, and some other tasks are also given. Task two. Let me put this as task 1. And coming to task 2. Okay, just observe the storage levels one more time, just to think through the storage level aspects. And now, however, task 3 is 3 members need to give the presentation. Okay, so presentation you can give, guys, after the break. Just will give the presentation from 12 onwards. Okay, these 3 are the tasks. Okay, so that's all, guys. Just we are reached to the end of the session. Let me quickly complete the key takeaways, because so that you can also feel the and you also parallelly type in the chat window, guys, please, so that other if I am missing out also, other members can see which are all the things we have discussed. Key takeaways. So very first point, we started with the persist and cache mechanism with RDD that we have seen. The second point we observed is storage level. And this particular storage level is 5 parameter, parameter 1, 2, 3, 4, 5. Your parameter 1 reference to the disk, parameter 2 reference to the memory. Parameter 3, guys, can someone help me? Reference to the
Use of
Heap.
heap.
Heap memory.
Use
heap.
of heap.
Very
Heap.
good. Heap. This is the deserialize. This is the deserialize. Just to remember this thing, guys, you need not by heart also. Because if you remember these things, if they are asking like this thing, memory, disk, 2, you can easily say that what is the replication true, second is also true, third is false, fourth is false, but last one is true, 2 replication. If you are going through this directly, you won't get any pleasure or understanding, guys. So you have to go this way. First you see the most generic way, then you need to go to the specific way, right? Okay. After this, we have seen broadcast and then accumulator. Now latest, we have seen the data frame create, of course, with list. And there we observed how data frame behaves with the collect or take. And we have observed how data frame behaves with show. Show is a tailor-made method. And we are having the print schema, and there is the analogy related to the print schema. Okay, so just with this, we are stopping here, guys. And of course, tomorrow I am also eagerly waiting how you guys are giving the presentations, because that is also part of the learning, guys. Okay, so I want to create some kind of the opportunity to you also, so that you can explore and exhibit your skills in front of our friends as a team. Okay, so that to a larger audience we are having from various BUs we are having, so that you can also have some peer learning or maybe additional aspects if I need to give to some senior members. So definitely I can do that also. Okay, thank you very much, guys, and see you back in the tomorrow session. And yeah, that's all. Okay, all the best. Thank you, see you back.
Thank you, sir.
Thank you, sir. Thank you, everyone.
Thank you, sir.